Hello everyone. In this video, we are going to see how to automate the start or stop processes in Linux using systemd service. In Linux, the systemd or system daemon is used for starting all the required processes during boot time or by manually using systemctl commands. So during boot time, the kernel will invoke the systemd and the systemd will start all the required processes like the processes corresponding to network, disk and so on. So this will be achieved by invoking corresponding service files. We also can start corresponding processes by using systemctl commands. For example, systemctl start or systemctl stop for starting or stopping the service. We also can enable or disable corresponding services by using enable or disable subcommands of systemctl. So when we want to automate the starting or stopping of Linux process, we need to write corresponding service file. So here we need to write a systemd service file. So when we are writing a service file, we need to identify what is the command or script for starting or stopping the process. For example, if we take the Jenkins application, which is a Java application, corresponding application will be started by java-jar jenkins.war. So this is the command which will be invoked by systemd service for starting the Jenkins application. We also can have this command inside a script as well. So in that case, the script will be invoked by systemd service during the starting of service. Similarly, we need to identify corresponding stop script or stop command for the process. So once the command or scripts are identified, we need to identify with which user corresponding process will be started or stopped. We also need to identify what are the environment variables will be used by corresponding command or script. And here the type will specify what is the type of the service. For systemd service, we have different types of services like simple, forking, exec and so on. For this demo, we are going to use the simple and forking type. So this success exit status will specify what is the successful exit status when systemd will try to terminate the process. So before going to the demo, let us try to explain about simple and forking. So for simple type, we will directly specify the command corresponding to the start process. That means when we start the systemd service, so corresponding command will be invoked directly and systemd will assign a variable main PID corresponding to that process. So when we want to stop that process, systemd will identify the main PID corresponding to the process and it will send a corresponding terminate signal as specified by stop command. So for simple type, the main PID variable will specify the PID corresponding to the command whatever we specify for start argument. The second case is with forking. So in the forking, instead of directly specifying the command, we will specify corresponding script. So this script will contain the command which will be invoked by systemd during the start of the process. So in this case, when we start the service, the systemd will create a process for the main script and this script contains this command. So during the execution of this command, this will in turn will fork a new process corresponding to the command. So it will have two processes, one for the main script and the child process corresponding to the command inside the script. So while doing this, after executing this child command, the parent process will be exited successfully and main PID will be assigned to corresponding child process. So when we stop the service, systemd will identify the main PID corresponding to the process of this command and it will send a terminate signal for the process. So to make this happen successfully, we need to make sure the process corresponding to the script should be exited successfully after executing the child command. If it is not exited successfully, we will get errors during the start or stop of the services. We will see that in the demo. So let us start the demo now. This is the service file we are talking about. Here we have different sections like unit, service, install and so on. In the unit section, we need to specify the description of the service. For example, for our Jenkins service, I have mentioned as Jenkins service. And here I have mentioned after. This will specify after which targets our service will be invoked. For example, here we mentioned network target and syslog target. So the processes corresponding to the network target and syslog target will be invoked by systemd. After that, our service file will be invoked. And this service section will specify how the service will be controlled. For example, for our service, here we need to mention the startup script or command and this will specify the script or command for stopping the process. The user and group will specify with which user the process corresponding to this systemd service will be invoked. The type will specify the type of the service. We have different types of services like simple, forking, exec and so on. For this demo, we will see simple or forking and success exit status. So this will specify the successful exit status of the process. For example, for Java applications, when we terminate a Java application using system commands, then it will return a non-zero exit code 128. In that case, for terminating the process, we are sending a signal 15. The total signal value, right? 128 plus 15. So this is the non-zero exit status of JVM applications, and 15 is the signal our system will send for terminating the process. So total is 143. So we need to mention this 143 as the successful exit status of the process which will be terminated by systemd. And there are many other parameters, but for this demo we'll use these simple parameters, and the install section will specify the trigger for this service. Generally when we enable the service, then during boot time this will be invoked by this target unit, which is multi-user target. So these are all the basic things we have to fill for our service file. Once the service file is prepared, we need to place it in one of these two locations. Generally the first location is used by the services which are installed by packages like RPM file and so on. And the second location is where our custom services will be placed. For example, our Jenkins service will be placed under this location. Now let us start implementing our Jenkins application. Once it is done, we'll also see about corresponding forking service as well. This is a Linux machine with Ubuntu operating system. The Java is already installed in this VM. Let us verify the same. So to manage the Jenkins application via systemd service, we need the Jenkins war file. Let us download the Jenkins war file first. For this, I'll create a directory /opt/jenkins. So we'll download the Jenkins war file and we'll place that war file in this directory. So this is the war file location. Let us click on it. So let me copy this link for downloading this war file. The war file is downloaded. So to start the Jenkins application, we need to execute this war file using Java command. So for starting and stopping this application, we'll create a new user, Jenkins. So let us create that user now. So firstly, I'll create the group. So now let us create the user, Jenkins. So for this, we'll use the same location what we have created now. And the group is Jenkins. So now the user is created. Let us try to log in with that user. So now we can see that the home directory is /home/Jenkins for the user. So let us provide the proper permissions for this Jenkins user. So here I am providing the ownership on home directory of Jenkins. And also we need to define the Jenkins home when we start the Jenkins application. So for that, let me create a new directory for Jenkins home. For this directory also, let us provide the ownership to Jenkins user. So now we have the Jenkins home and also we have the war file. So before creating a systemd service file for this Jenkins application, let us verify whether the startup is working or not. So for this, we'll use the Java command to start this application. Before that, let me set the Jenkins home variable. So let us execute the Java command now. So this command will use this Jenkins home variable to store all the Jenkins information in this directory. The Jenkins application is started. That means our command is fine. We'll use this startup command inside our service file. So let me provide Ctrl+C to exit this. So the Jenkins is stopped now. So we can verify whether the directories are created inside varlib Jenkins directory. Here we can see that all the directories are created. So let me delete all these directories because we'll try to implement the same using our systemd service file. So now we don't have any directories inside our Jenkins home. Let us also verify if any Java process running in this machine. There is no Java process corresponding to Jenkins. Now our startup command is working. So now let us fill this service file with all the required details. So here we have created the user and group as Jenkins. And initially we'll use the simple type. That means we'll use the command directly in the execution start command. For the environment variable, we'll use the Jenkins home. Let us define the same here. The start command needs to be provided here. So when we specify the commands here, make sure we enter the full paths of the executables as well as the required files. So the var file is present under opt jenkins. So for Java, let us give the full path of Java executable. So this is our startup command. So for stopping the process, we'll use the terminate signal of kill command. So for this, we need to provide the process ID as the main PID, which was created when we start that process. So this should be kill command with a signal 15, and the process ID is main PID. And for kill command, let us give the full path /bin kill. So success exit status will be 143 as we discussed earlier. So we'll use these details and let us create a service file, and we'll place this file under etc systemd system directory. So let us go to the etc systemd system directory. Here let us see the files. Here we can see other service files like sshd, syslog and so on. So let us create the Jenkins service file here. So I am copying this content there. Let us save the file. The service file is ready. We need to reload the systemd daemon to make these changes in effect. Let us do that. Now the daemon is reloaded. Now let us start the Jenkins service using systemctl command. Here I am providing Jenkins because the service name is jenkins.service. The start command is executed. Let us verify the status. Now we can see that the status is successful. Here we can see that the service is active and it is running with a main PID 2377. So this is the main PID which is assigned to the process which is created by executing the execution start command. We can also see this process using ps command. So this is the process ID which is corresponding to our main PID. And here we can see that the command which was executed is the same command which we entered in the service file. We can also verify the Jenkins content in the where lib jenkins directory. Here we can see all the required directories which are created when we start the Jenkins application. Now let us stop the Jenkins application by stopping the Jenkins service. For that again we will use the systemctl command. So when we stop this service, it will kill the process corresponding to main PID. So let us verify the process again. Here we can see that there is no Java process corresponding to main PID. We can also verify the status using systemctl command again. Here we can see that stop Jenkins service and the service is inactive or dead state. So that means our stopping is also successful. So in this way we can create a systemd service file using simple type. Now we have seen how to implement a systemd service using simple service type. Here we have directly entered the command for starting the service, but in some cases these commands will be part of some scripts like shell scripts or Python scripts and so on. So in that case we cannot directly provide the command here, so we need to provide the script. Then when we start the service, the script will be executed. So this execution will create a process, so that will have a process ID, and during the execution of script the command will be executed. For example, our Java command will be executed as part of the script. So this also will create another process ID. So this process will fork another process for executing our command. In this case, our service type will be forking. So when the forking is done, systemd will wait for the completion of the script. So when the script is completed, then only it will allocate main PID for the process corresponding to this command. Unless the script exits, this command cannot be allocated main PID. Once main PID is assigned to this process, then the remaining part is similar to our simple type. So when we stop the process corresponding to the main PID, that means our child process will be exited. Let us see that in the demo now. So now let us change the service file. The type should be forking, and we'll place this start command in a shell script. So here I'll put jenkins.sh. So let us use bash shell for this. So this is a simple shell script. Let us save the file. So now the script is ready. Let us use this script in the service file. So let us replace this with the script path. So now let us replace the systemd service file content with this. Let us save the file content. So the systemd service file is changed now. So we need to reload the daemon. The daemon is reloaded. So before starting the service, let us delete the content of Jenkins home. Now we don't have any files or folders inside the Jenkins home. After starting the service, we'll see whether these directories will be created again. So let us start the service now. There is an issue with the starting of the script. Let us check the status. So we don't have permission to execute the script. Let us provide the permission. The permission is given. Let us start the process again. This time the service is getting started, but it is taking time. So we need to find the reason why it is taking a lot of time to start the process. The Jenkins service is failed because a timeout was exceeded. That means the child process is not getting allocated a main PID because the parent is not getting exited. Here if we execute the script manually, so it is starting the Jenkins application, but the problem is this is not getting exited. So we have to press Ctrl C or something once the process is started. Here I am pressing Ctrl C. So that means the process is exited now. So we need to change our script to run this Java command in background so that the parent process can be completed. So let us change the script now. Here I will run this child command in the background. So after executing this command, so this will run in background so that the main process will be completed. So once the main process is completed, the main PID will be assigned to the process corresponding to this command. So let us save this file and start the service again. So the file is changed now. So before starting the service, let us see if any Java process running. So there is no process running corresponding to Jenkins. So let us start the service again. So this time we did not get any timeout error because the parent process exited successfully. Let us see the same using status command. So from the status we can see that there is a process 2318 corresponding to our shell script, and also we can see another process 2319 corresponding to our Java command which is part of the shell script. So here we can see that the 2319 process ID is the main PID because the parent process 2318 exited successfully. So now the main PID is corresponding to our child command which is our Java application. So when we stop the service, this process will be terminated. Let us see with ps command also if any Java process running now. So here we can see that the 2319 is running, which is our Jenkins application. So that means when we execute commands via the shell scripts or some other scripts, we need to make sure the parent script will be exited successfully so that the main PID will be assigned to the required child command. So now let us stop the service. So the Jenkins is stopped successfully. Let us verify if any process running. So there is no process, and also verify the status. Here we can see that the Jenkins is stopped successfully. So this was corresponding to the previous start when we have got the timeout issue. So this way we can implement the systemd service using forking method. We can also do one more operation like enabling and disabling the service using systemctl. So when we enable it, this service will be automatically started when we boot the operating system. When we disable the service, this service will not be started automatically during the rebooting of the operating system. So let us try to enable the service now. So now the service is enabled. We can also disable using systemctl command. So the service is disabled now. That means it will not be started when we boot the operating system. So in this video, we have seen how to automate the start or stop of Linux process using systemd service. Here we have considered two types of systemd service like simple service and forking service. And we have taken the example as Jenkins application. I hope this video helps. Thanks a lot for watching.